American pilots inspected a downed Zero fighter. They were amazed at the Japanese innovation. For those of you who follow WW2 Pilots, prepare yourselves for one of the most important and least told stories of the turning point of the Pacific War. I vividly remember the first months after Pearl Harbor. The word circulating among us pilots was Zero. It wasn't just a plane. It was a phantom, a war machine that seemed to defy the laws of aerodynamics and logic. When Japan attacked, the Mitsubishi A6M0 not only destroyed our fleet on the ground, but also swept the skies of any Allied fighters that dared to engage it in a dogfight. The reports were grim, almost unbelievable. Our F-4F Wildcats and P-40 Warhawks, aircraft we trusted, were simply being scrapped. We had pilots returning with stories of a fighter with incredible range that could turn tighter than anything we had designed, and that seemed untouchable. Zero quickly built a myth of invincibility that shook morale and forced our strategists into a terrible dilemma. How to fight an enemy whose capabilities we knew nothing about. We had to shoot it down, but most crucially, we needed one of our own. We needed to understand the demon we were facing. The truth is, at first, we had no idea of the ingenuity and extreme focus that Japanese engineering had invested in that aircraft. What we discovered later, upon inspecting the first nearly intact Zero, would forever change the way we fought in the Pacific. The search for this secret became our obsession. It was a race against time, where every day of ignorance cost American lives. And that day, the day we got our hands on one, was about to arrive in the most unexpected place. A frozen swamp in Alaska. Our big break came, ironically, from a Japanese disaster. In June 1942, Imperial Japanese forces attacked the Aleutian Islands in Alaska as part of their strategy to divert attention from Midway. It was against this backdrop of ice and fog that fate handed us a priceless gift. A young non-commissioned officer named Tadayoshi Koga was piloting a Model 21-0 during the attack on Dutch Harbor. He was hit. A shell from an American ship ruptured the oil line, and Koga, following strict Japanese orders that downed aircraft not fall into enemy hands, flew toward a predetermined emergency area on Akutan Island. It turned out the chosen area was a muddy, partially flooded swamp. While attempting a belly landing, the Zero's wheels became stuck in the mud, and the aircraft overturned. Koga was killed instantly, but the Zero remained, almost unbelievably, virtually intact. Structural damage was minimal. The main thing was the capsize and the engine. Days later, a U.S. Navy reconnaissance plane spotted it. At first, it wasn't obvious what we'd found, but when rescuers arrived on the island, they were astonished. It was a complete Zero, and it was on American soil. The importance of this find couldn't be overstated. It wasn't a rusty hunk of scrap metal at the bottom of a tropical sea, but a nearly complete machine, ready to be studied. And to ensure the opportunity wasn't lost, a secret and complex recovery operation was immediately put into action. Having a Zero in our hands meant, finally, we could debunk the myth and, more importantly, survive it. The discovery of the Akutan Zero initiated one of the most urgent and secret intelligence operations of the time. Our command knew that if the Japanese discovered we had found a nearly intact Zero, they would do everything they could to destroy it. The plan to extract the aircraft from the Akutan swamp was complex and demanding. The island was remote, and the weather was relentless. We had to use a salvage ship, and with the help of heavy equipment and brute force amidst the mud and Arctic weather, the Zero was carefully turned over and towed. It felt like the painful birth of a war machine. I remember thinking that every scratch on the fuselage was a loss of vital information. Therefore, the aircraft was treated with the delicacy of an archaeological artifact. Once hoisted onto the deck of the transport ship, the Zero was wrapped and transported under the strictest security to North Island Naval Base in San Diego, California. Secrecy was absolute. The landing of that fighter on continental American soil was a monumental intelligence event, a victory that involved not gunfire or bombs, but pure knowledge. We weren't just unloading a plane. We were unloading the key to unlocking the secret of Japanese air supremacy. What followed were months of meticulous work, transforming Koga Zero into a prize of war that would become the centerpiece of our effort to turn the tide of the air war in the Pacific. When we finally got to inspect Koga Zero in San Diego, The first thing that struck us was the radical lightness. Our engineers and test pilots were shocked. The Zero weighed considerably less than our fighter counterparts. It was a stark difference. We immediately sensed that the Japanese obsession with maneuverability and range dominated every aspect of the design, and this was the root of their innovation. They used an extremely lightweight aluminum alloy, which minimized wing loading and allowed the aircraft to fly farther, and with an agility that humbled us. I remember one engineer comparing the Zero's structure to that of a glider. It seemed so delicate. They had optimized every screw, every rivet to eliminate unnecessary weight. The engine, a Nakajima Sakae, although less powerful than the large Pratt and Whitney engines we used, was incredibly fuel-efficient, explaining the nearly $3,000 kilometer range. This was the secret behind the Zero's myth. It wasn't brute force, but aerodynamic elegance and weight sacrifice. This realization in itself was a surprise. We realized that while we prioritized power and protection, the Japanese prioritized agility and persistence in the air. It was there, in that hangar in California, that we began to understand the price they paid for this lightness. And it was this price that would give us the advantage. One of the aspects that left us most speechless, and that defined Zero's threat, was his operational range. When we dismantled and inspected the fuel tanks, the magnitude of Japanese innovation became clear. In 1942, our best carrier-based fighters could barely cover distances that the Zero easily covered. This combat range was simply on another level. This was not just an engineering feat, but a fundamental war strategy. This capability allowed Japan to project air power over vast stretches of the Pacific, operating from relatively distant islands. I remember our frustration in combat. Often, when we thought the Zeros might be out of fuel, they kept coming. This range gave them tactical and strategic flexibility that we initially lacked. The Zero's engineering, focused on the efficiency of the Sakae engine and extreme weight reduction, allowed it to carry more fuel in proportion to its weight, and to use it more sparingly. But innovation had a dark side. To achieve this monumental range, the Japanese sacrificed safety. It was a calculated choice. More fuel meant more range, but the lack of self-sealing tanks meant a hit could be fatal. It was the first major clue as to how to defeat them. The Zero was a high-performance athlete, fast and agile, but incredibly fragile. This fragility was the Achilles heel we were desperately searching for. If the lightness surprised us, the almost total absence of armor shocked us and revealed Japanese design philosophy. When we opened the cockpit, when we examined the structure, we found no armor plates behind the pilot's seat, nor any significant protection for the fuel tanks. To us, this was heresy. Our fighters, the Hellcat that would come to dominate and the Wildcat we used at the time, were built to absorb punishment. We prioritized pilot protection and the ability to return home. With the Zero, we realized that the pilot was considered an expendable part of the equation for achieving maximum performance. There was no flak jacket for the aircraft. The decision to sacrifice armor was the price the Imperial Japanese Navy was willing to pay for speed and maneuverability. The fuel tanks, as I mentioned earlier, were the most vulnerable point. They were simply ordinary tanks, without the self-sealing coating that had become standard on our aircraft. This explained why a single hit from our .50 cal machine guns was often catastrophic for a Zero. It burst into flames with alarming ease. This discovery was fundamental. Japanese innovation was brilliant in aerodynamics and range, but lacking in safety. We had the knowledge. Now we needed the tactics to exploit it. The inspection gave us more than just pieces. It gave us a map of the enemy's weakness. Getting the Akutan Zero back in the air was a triumph of our engineering. After months of meticulous repairs, the aircraft was ready to fly. The man chosen for this historic mission was Lieutenant Commander Eddie Sanders. He would become the first American pilot to fly a Zero in American colors. The goal was not just to fly, but to push the aircraft to its limits to understand the exathlete our pilots were facing. Sanders' first reports confirmed the myth. At low speeds, the Zero was a masterpiece of agility. It could execute maneuvers at speeds and radii our Wildcats couldn't even dream of. Its cornering ability was simply spectacular, which explained why getting into a dogfight flying straight at it was suicide. Sanders described the experience as like flying a very light and responsive aerobatic plane. However, he also discovered the first major Achilles heel of Japanese design. Innovation focused solely on lightness had neglected a crucial factor in modern combat. Terminal diving velocity. The Zero couldn't handle high speeds. When diving to gain speed, aerodynamic compressibility affected the controls, making them incredibly heavy and ineffective. Sanders realized that, in a fast dive, a Zero pilot would completely lose control of the maneuver, becoming a sitting duck. It was a huge relief. We had discovered a viable defensive maneuver. If a Zero was on our tail, the response was not to turn, but to dive and run. This changed everything. Eddie Sanders' discovery of the Zero's diving limitations was the tactical turning point we'd been waiting for. Think about it. The lightness that ensured the Zero's maneuverability was simultaneously its greatest structural and aerodynamic weakness at high speeds. In a traditional dogfight, when a Zero managed to position itself on the tail of a Wildcat, the usual tactic would be to try to outturn the enemy. But now we knew the truth. If an American pilot was being pursued by a Zero, he shouldn't try to turn. The answer was to accelerate and dive straight as quickly as possible. Our most robust fighters, with their powerful engines and reinforced structures, could withstand the stress and speed of the dive. The Zero could not. Inertia and aerodynamic forces simply locked their ailerons and controls. The Japanese pilot couldn't follow the dive without risking wing disintegration or completely losing the ability to point the nose at the target. This gave us an escape tactic and, more importantly, an attack tactic. If you could fly above a Zero, you could dive, fire, and escape, using speed and altitude as armor and advantage. It was the formula for turning the tide. The Zero, the king of maneuverability, was now vulnerable to pure and simple physics. That aircraft shot down on the icy island had given us the instruction manual for its destruction. Detailed analysis of the Zero's capabilities not only gave us defensive tactics, but also spurred the development of new offensive formations that neutralized Japanese maneuverability. The most famous of these was the Thatch Weave, developed by Lieutenant Commander John Thatch. Before we obtained the Akuten Zero, Thatch had already theorized that the key was to use the enemy's speed against it. Inspection of the Zero, however, confirmed that this was the only way to survive. The Thatch Weave involved two fighters flying side by side, with a specific distance between them. If a Zero attacked the tail of one of the fighters, the American pilot would dive to the opposite side, and his wingman would fly toward him, crossing the trajectory. This forced the attacking Zero to either pass through the fire of the second American fighter or break off its attack to avoid collision. The Zero's agility in entering a dogfight was overcome by this team coordination. It was a brilliant concept, turning our fighter's tail vulnerability into a death trap for the Japanese fighter. The Zero might be a master of the individual turn, but it couldn't handle the radio-coordinated team tactic. This tactic, combined with our aircraft's diving ability, turned the initial disadvantage into a devastating tactical superiority, allowing our pilots to begin racking up consistent victories, even with the Wildcat. While the Thatch Weave was a defensive and double engagement tactic, the discovery of the Zero's diving limitation gave rise to the most dominant tactic of the late war, the boom and zoom. This tactic was the embodiment of the American philosophy of brute force and protection. We knew we couldn't beat Zero in the turn, but we could beat it in power, speed, and altitude. The tactic was simple but lethal. Climb higher than Zero, dive at high speed to attack, boom, fire at the vulnerable target, and use the energy of the dive to climb back out of the fight, zoom, returning to the safety of altitude. Never, under any circumstances, should the pilot slow down or engage in a turning duel. Our heavier fighters, like the P-38 Lightning and, later, the F-6F Hellcat, were perfectly built for this. They could withstand the speed of the dive, and their robustness meant they could take more bullets. This was the antithesis of the Zero design. Zero was a marathon runner, our fighters were weightlifters. By forcing the fight to be resolved by speed and altitude, not maneuverability, we eliminated the Japanese's main advantage. Akuten Zero not only revealed to us what the enemy was, but more importantly, it taught us what we must be to defeat him. The greatest result, and perhaps the greatest irony, of the Akuten Zero inspection was the acceleration and refinement of the fighter design that would eventually dominate the skies of the Pacific. The F-6F Hellcat, the captured Zero, served, literally, as a requirements manual for the Navy's new fighter. We now knew what the enemy could do and, more crucially, what it couldn't do. The Hellcat was designed to be the antithesis of the Zero. Instead of lightness, the Hellcat prioritized robustness, with a steel underbody plate to protect the pilot and self-sealing fuel tanks that made it incredibly resistant to damage. Its engine, a Pratt & Whitney R2800, generated over $2,000 horsepower, almost double that of the Zero's Sakai engine. This power allowed the Hellcat to climb faster, dive faster, and, of course, fly faster. If the Zero was the light eagle, the Hellcat was the heavy hammer. It was made for boom and zoom combat. The Hellcat's kill ratio against the Zero, reaching 19-1 in some battles, is the ultimate testament to the importance of that Zero shot down in Alaska. Thanks to the knowledge gained, the Hellcat not only equaled but surpassed the Japanese threat, ushering in the era of American air superiority in the Pacific. Japanese innovation forced us to innovate faster and harder, and the Hellcat was the result. In addition to the tactical and technological changes, the recovery of the Akutan Zero had incalculable psychological impact about our pilots. Remember, for months, the Zero was seen almost as a magical, unattainable machine. The myth of Japanese invincibility hung over us like a dark cloud, undermining confidence in dogfight. When test reports of the captured Zero began to circulate, the mystique was shattered. Suddenly, the Zero was no longer a ghost. It was a machine with known and exploitable flaws. I can tell you that our squadron's morale soared. Knowing we could dive and escape, or use the thaw weave to turn the tide, transformed fear into a tactic. Our pilots now entered combat knowing they had the information advantage. They knew that if they forced the Zero to fly too fast or dive, the Japanese pilot would be in serious trouble. This shift in perception was as vital as the introduction of the Hellcat. Air warfare is fought in the mind as much as in the sky. The Akutan Zero didn't just give us engineering data. It gave us the confidence to fight and win. It transformed a feared aircraft into an engineering problem with a clear solution, taking the Zero off its pedestal of invincibility and placing it on the battlefield where its weaknesses would be ruthlessly exploited. As we studied the Zero's design, we began to understand the dark philosophy behind its innovation. The decision to sacrifice armor and self-sealing tanks wasn't just an engineering choice. It reflected Japanese war doctrine, which placed little importance on the preservation of its pilots. Japanese designers focused entirely on performance at the expense of safety. The human cost of this choice was evident in our combat reports. When a Zero was hit, it often disintegrated or burst into flames immediately. Our pilots, flying robust aircraft, could take severe punishment and still return home, often with minor injuries. Japanese pilots, on the other hand, had a much lower chance of surviving a hit. This difference became a decisive factor as the war progressed. While our survival rate allowed aces to gain experience and train new recruits, Japan was losing its elite, experienced pilots at an unsustainable rate. The Zero was a brilliant fighter for an exceptional pilot, but its fragility ensured that Japanese pilots lacked the opportunity to make mistakes and learn. Japanese innovation, sacrificing pilot safety for maximum performance, ultimately became a death trap for the Imperial Air Force, ensuring that Japan was left without qualified pilots at the very moment it needed them. Our inspection also immersed us in the battle of materials that defined the confrontation in the Pacific. The Japanese made extensive use of sucrol, an aluminum and zinc alloy, to build the Zero. This material was vital for its lightness and agility. It was, indeed, an impressive innovation for its time, allowing them to achieve flight performance that initially surpassed ours. However, zinc alloy came at a cost: fragility. In contrast, our aircraft, like the Hellcat, used aluminum and steel alloys that, although heavier, provided far superior strength. The Zero flew light and agile, but its structure was more susceptible to damage in high-energy combat. To withstand the G-forces of rapid dives and the punishment of enemy fire, the Hellcat and Corsair were built like flying tanks. The Japanese innovation was light and delicate. Ours was heavy and durable. What we learned from the Akutan Zero was that structural durability and the ability to absorb damage were more important to winning an industrial war than extreme maneuverability. Our robust twin engines and reinforced wings withstood the fire that destroyed the Zero with ease. This fundamental difference in materials choice and design philosophy sealed the Zero's fate as the war progressed and American industry accelerated production of more powerful fighters. The story of the Akuten Zero is essentially the story of the decline of Japanese air supremacy. What was a revolutionary fighter in 1940, the best in the world, quickly became obsolete, largely because it provided the blueprint for its own destruction. The knowledge we gained allowed our strategists and engineers to work together to create the perfect response. Once the F-6F Hellcat, followed by the F-4U Corsair, began arriving in large numbers in 1943, the Zero, despite minor improvements, could no longer compete. It was slower, had a lower rate of climb, and, crucially, was much more fragile. Our experienced pilots, armed with boom and zoom and thatch weave tactics, knew how to exploit every flaw. Japanese losses soared, and pilot replacement became impossible due to the high casualty rate and inadequate training. The Zero, which began the war as the symbol of Japanese innovation, ended it adapted for desperate missions. Kamikaze, it's a melancholy end for a machine that required so much ingenuity. But for us Allied pilots, the Akuten Zero was the game changer. The piece of intelligence that allowed us to turn the tide in the Pacific and secure victory. That plane in an icy swamp taught us the most important lesson of aerial warfare. And so, my fellow WW2 pilots, we conclude the journey of a single aircraft that changed the course of an entire war. The Mitsubishi S6M0, Model 21, found on Akuten Island, was not just a trophy. It was the master key that unlocked the mystique of the Japanese Air Force and saved countless American lives. That inspection taught us that innovation, when pursued at any cost, has a tipping point that can be exploited. The Zero was an agile, lightweight aircraft that taught us how to build a tank destroyer and how to use power and speed as our greatest weapons. I hope you enjoyed delving into the tactical details and engineering stories that shaped aerial combat in the Pacific. The history of World War II is filled with unexpected twists and turns and cutting-edge technology, which is why your support is vital. If you value this kind of in-depth analysis of aviation and war tactics, please leave your like in this video, share with other enthusiasts, and, most importantly, subscribe to the WW2 Pilots channel so you don't miss any of our upcoming story missions. Your subscription helps me continue telling these crucial stories. And for our next video, we'll take a brief break from the hectic skies of war to explore logistics and ground supply delivery. We'll explore a surprising topic: farms and ranches in World War II. How American farming fueled the Allied war machine and kept pilots flying. Click the bell to be notified and see you there.